Chapter 6, number 47. When you take your 1900 kilogram car out for a spin, you go around a corner of radius 53 meters with a speed of 13 meters per second. The coefficient of static friction between the car and the road is 0.88. Assuming your car doesn't skid, what is the force exerted on it by static friction? So if we look sort of from above, we have the car and it's doing some sort of circle like this. And let's assume at the moment we care about we're right here and the car is going this way with speed v in a circle of radius r. Then from above, the only force acting is the force of friction, which points force of friction, which must be pointing towards the center of the circle. And we'd also have, this is sort of a top view. If we had a side view, then we would have the car, and we'd have the weight and the normal, and the friction pointing towards the center, something like that. We also know that because we're going around the circle in the way indicated, there is a centripetal acceleration towards the center, whose magnitude we know. The centripetal acceleration will be v squared over r. So, if we consider just the horizontal force, that's the frictional, would be the frictional force, but the horizontal force would also be the mass times the acceleration, or mv squared over r. So we see pretty logically that these two things very quickly become the frictional force is mv squared over r, which is 1900 kilograms times 13 meters per second quantity squared over 53 meters, and we get 6175 newtons, which based on our 2 digits of accuracy is really 6200 newtons, which Walker, I'm sure, reads as 6.2 kilonewtons. You might wonder, why do they even bother giving us the coefficient of friction, since we end up using it? But what we really need to do here is to verify what would the maximum force of friction be. So the maximum force of friction is mu times the normal, which in this case will be mu times mg, or 0.88 times 1900 kilograms times 9.81 meters per second square, or 16402 newtons, which is 16 kilonewtons. And that's a good deal because we found that the actual maximum force, the actual frictional force, is in fact less than its maximum value. So we're happy.